At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
Jad Tawil is the CTO and co-founder of Nexus Robotics, which is a Quebec-based robotics company focused on the agricultural sector, developing autonomous robotics solutions. They created Nexus to address three major problems: labor, chemicals, and climate change. As their beachhead solution, Jad and his team use machine learning to tackle the jobs no one wants to do anymore: weeding vegetables. In our conversation, Jad talks about how they started Nexus, why the agricultural industry needs robotics, and what are the big applications in the future he has ambitions to tackle as their solutions continue to mature. Hope everyone enjoys the show. Here we go. Hi, Jad. Thanks for joining me today.
Thank you. Thanks for the invite.
Yeah, no, it's great to be able to sit down together, and we share the same building, and so whenever I have customers come, I always have to include you guys in my tour because it's just such cool things that you guys do.
We try our best to be as cool as possible.
Yeah, you're doing a great job. So tell me a little bit about Nexus, and you're one of the founders of Nexus Robotics. So tell me, let's start off, how did you get into robotics?
Sure. Well, I got into it through by starting Nexus. I wasn't a robotics engineer prior. I didn't have an explicit interest in robotics prior to this. Me and one of the other co-founders were working on a farm, actually, an organic farm. I did that right after I finished my undergraduate in engineering. And he had the idea of like a robot to pull weeds because we were doing it by hand. And it seemed extremely far-fetched at the time. We approached a university professor at Dalhousie with this idea, and he was able to get us some starter money, some grants just to kind of get us going, building our first prototype. And that's when it became less far-fetched and became a real thing. And that's when I started learning robotics, essentially, and computer science and all the different things that are required technically. So I'm the chief technical officer, and it was my responsibility to kind of design the software and kind of scope all the concepts, I guess, that are needed to accomplish the task at hand, which is just to build a machine that can pull weeds. And then fast forward, it's been 6 years now, and here we are. So yeah, the idea came about from like a real world sort of facing a certain problem. And yeah, we and it's three co-founders, and we each played a very kind of critical role to get it going. So myself on the technical side, Thomas Trappenberg, a professor who's still a professor at the Dalhousie University. He was tremendous in terms of giving us like guidance. He's far older and more experienced, and his professorship allowed us to get some grants to get going. And Tarek, the third co-founder who had the idea of doing it in the first place, was kind of leading the business development side of things early on. And so that's kind of how it started. Okay,
very interesting. Yeah, and one of the things that I'd like to maybe talk a little bit about it, because from when I studied engineering, so I graduated in 2000, and back then, in terms of engineering, robotics, there wasn't many disciplines specifically focusing on robotics in the engineering faculties. Now it's changed a lot. There's many different flavors of robotic programs mixed with computer science that people can get into. And so we're starting to see, folks, I know you didn't study robotics, but young folks like yourself coming out with these cool ideas. And I love the storyline that in Canada, you were able to find grants that helped you get going. So I don't know if you mind sharing a little bit about the types of grants and how Canada is supporting this type of innovation.
To be honest with you, I don't remember the exact grants that we got early on, at least their names or
Yeah,
even which organization gave them to us. And that's just because it wasn't really my responsibility to manage that stuff. I was solely focused on the technical side of things, and Tarek and Thomas at the time were more, they were just handling the acquisition of funds. So,
gotcha.
yeah,
Your
I
mission
can't.
was to make this thing work.
Yeah, exactly.
Gotcha, gotcha. Well, I was poking around your website and um, there was some news, I believe from the summer, where you guys did receive another grant for Sustainable Development Technology Canada, which
Mhm.
focuses on clean technologies. So I'd love to hear a little bit about how your robotic system um, is fits into the clean technologies, and what are the benefits for farmers and what type of crops do you guys typically go after?
Yeah, sure. I guess it fits into the clean tech world by um, hypothetically reducing the need for herbicide by pulling the weeds mechanically. You won't need to use herbicide as much, and thereby you don't need to invest as much into making crops resistant to herbicide. So there's savings on both those fronts. Um, so that's how it fits into the clean tech world. Uh, the robot itself is technically, the way we've designed it is a hybrid between diesel power and we're going to add some solar panels on the top of it as well, which will make it more clean going forward. Um, and so that's how it fits.
Okay, okay. And what type of um, crops are really benefit to avoid herbicide? Is there specific, vegetables that you guys specialize in?
We focus on the not on the cash crops like
Okay,
corn and things like that, but the high value crops like lettuce and onion and carrots and cabbage and things like that. We've kind of refined our focus further onto just lettuce, just to um, it's best to kind of focus on one thing at a time and master one domain at a time. And we chose lettuce to do that because we were performing best on that. In terms of which crops are more sensitive to herbicide than others, I'm not sure. I'm not a farmer or botanist. I know that they're all somewhat sensitive to these things. If I had to answer, I would say onions, because I've seen their leaves yellow after the spraying of herbicide myself, but I can be wrong on that too. And so yeah, that's all I can say.
yeah, yeah, no, okay. It makes sense, and I think in general, you see a lot more push towards uh, sustainable methods of farming and stuff like that. So um, I can definitely see uh, this type of solution helping with that. And not only that, the business that we're in too, just finding people to do this labor intensive work. So
Yeah.
you mentioned at the beginning you were picking weeds um, as a job. Yeah, growing up, I picked a lot of rocks as a job, and those are not fun jobs, and nobody necessarily wants to do them. But it's also an unending job. You're never finished too.
No,
So um, yeah, I can see this being an important um, uh, element for a farmer to be sustainable, not only from herbicide standpoint, but economically, and just have a better crop year to year.
totally. I mean, I'd say the main value proposition that our product, I guess, is the reduction of manual labor. I think that the sort of clean tech aspect to it is significant, but the most pressing need is to simply automate this strenuous task that really nobody wants to do. I mean, certainly no Canadians will be paid to pull weeds on a farm. None of them would ever take that job at minimum wage. And so the workers are brought in from other countries, and these are skilled workers because they are usually farmers or have farming experience from their own countries. They're not just random people. And, it's best to use skilled workers for, jobs that require skill rather than no one wants to do this, even the migrant workers. You would rather deploy them on more, I guess, complicated and sort of higher level tasks than just being in the middle of a field pulling weeds. It's certainly not part of our future, I think. And currently the main method for weed removal is by hand by a troop of people. And not to mention the health consequences of, working in the heat is one thing, but as humans, we've done that forever. So it's more so the bending over, the, contorting your body in a very sort of awkward way, where, you're standing between crop beds that are, a foot wide, and you have to place your feet in it and lean over the bed where you don't want to smash the crops. So it's just an awkward balancing act, and you're doing that for hours and hours on end. It's just if you've ever done it for 30 minutes, you'll know what a terrible job that is. And that's kind of the main sort of value that we bring, is that we just relieve people from having to do that. And obviously, if we do it effectively, more effectively than human beings, by having a autonomous robot that can operate 24 hours, and we decrease the need for herbicides, that's an added benefit, and that would be great. But the main kind of pain point is just manual labor. And through the pandemic, this was highlighted even more, because they were having a hard time bringing in migrant workers for COVID reasons and such. And if they had a COVID outbreak on the farm, for example, then everyone has to quarantine, and so no one's weeding the fields, and that happened several times. I mean, inevitably, you're going to have these outbreaks too. If you have a robot, then obviously, that's not a problem. So over the last few years, the need for a technology like ours was highlighted more than ever. Now, I think we're past the pandemic. I mean, I'm sure still there are measures taken, but it's not nearly as we're not nearly as guarded as we were before, and thank God for that. But still, getting migrant workers to come in, period, is very difficult. Several farmers that we've worked with had problems actually getting the staff that they wanted, and they still do. And so I think robotics and automation on farms is inevitable for seeding, weeding, harvesting, disease recognition, pest detection, all these things. And we plan on touching on all those things in the future. Weeding is our flagship service. It's going to be the first thing that we do, because I think it's more straightforward than harvesting, and more valuable than seeding. So it'll get us on the fields, generating revenue, getting the machine running, and then we'll start offering these additional features later in the future. But only when we've mastered the weeding, which we have yet to master. I mean, we're effective, but there's room for improvement because it's complicated. It's very, very complicated. And I can explain the technical complexities of it later, but I think that's good for now.
Yeah, no, it's a very dynamic environment, and I'd love to jump into the technology part. And my son, he loves to watch on YouTube The Millennial Farmer, and I don't know if you've seen that YouTube channel, but farming is actually a pretty high-tech industry. A lot of the equipment, they're very impressive machines, and there is a lot of tech that goes into some of these large-scale farms. So, what I think for robotics, it's a great industry, and I think the farmers, at least the newer generation farmers, are embracing technology. So I think you guys are in a very interesting spot.
Yeah,
Now
absolutely.
let's talk a little bit about the robot itself. So you mentioned you offer this as a service. So you guys are running the robot in the weeding process?
Yeah, I mean, it is autonomous,
Okay.
but obviously bringing it to the field, mapping the field, making sure that it's working well, monitoring it remotely, and troubleshooting it in some situations, handling other situations where, um, you know, uh, like certain failures that may occur, because it's a new technology. The idea was to provide it as a service simply because it wasn't yet ready to be kind of packaged into a product that is bought, and a farmer can just completely control it and get the reliable results that they want. So in some ways, as we're kind of like commercializing and developing at the same time, and so doing that with a service model made the most sense. So we do bring it to the farm, offload it off a flatbed, deploy it ourselves, and make sure it's working remotely and locally, depending on the kind of tests we're doing. And it's completely hands off for the farmer. And I think that that's really good idea because um, farmers definitely love technology, but they also are entrenched in their sort of habits and the ways that they do things. And imposing a new technology on them is a bit of a tough sell. So telling them, well, hey, take this and I promise it'll work fine for you, is a little tough. Instead, what we say is, well, we guarantee your fields will be weeded. Um, and that's it. And they're like, wow, okay, great. And we tell them, well, you don't have to worry about the robot. We'll handle it. We'll make sure it's working as it should. And they're like, okay, well, that's good for me. I don't need to mind it very much. I don't need to worry about it very much. And so that's how we do things.
Yeah. Yeah. So instead of bringing in these migrant workers, they're bringing in a robot, and you guys are performing that service. So you said you bring it in, offload it off a flatbed truck, and then the first step is what? Is mapping the field?
Um, yeah, totally. I mean, the robot uses GPS for navigation.
Okay.
And we essentially need to, what we do is when we arrive, we map the crop beds. We essentially just know the GPS points. We figure out the GPS points that the robot needs to kind of follow, so that it's kind of going over the row,
Okay.
and so we collect those points upon arrival. It's a kind of a 30-minute job, and once the field is mapped, then the robot can essentially navigate autonomously. There are other ways of doing this, by the way, kind of more complex and fancy ways, but I don't like them very much. For example, you can use vision, like you can have a camera at the front of the robot and it can kind of detect where the crop beds are and properly kind of segment the sensory data and figure out, okay, this is crop bed 1, 2, and 3, and then it can kind of on its own control itself and navigate and do this stuff. And that's definitely on the horizon for us, technically, developmentally speaking. But it's not something that we need right now to just get it going, because the bulk of the value we present isn't necessarily a self-navigating robot, but rather a robot that can detect crops and weeds and pull the weeds,
Right.
So we put most of our energy on making sure that that works well. And the navigation, which is just the part of the software that commands the wheels, we try to simplify it as much as possible by simply following GPS waypoints. And that works really well because we use RTK GPS, which is a common technology that like autonomous tractors use. It's essentially accurate to within a centimeter to 2 centimeters, which is really, really crazy. And therefore you can kind of navigate a row with keeping the wheels on the path, on the kind of on the path, I guess, which is only a foot wide, right? So you have to very accurately, to within a few centimeters, know where you are in the world. And thank God technologies like that exist, because without that, what we're doing would not be possible.
Yeah. So how long does the setup time, unloading and having this ready for weeding?
Yeah, it's somewhat variable because so the constant parts of the setup time are obviously unloading it and mapping the field. That only takes 30 minutes, maybe an hour if it's a big field, or it's a field with a lot of interesting turns, and the rows aren't very straight, and you have to kind of account for that.
Okay.
But it's more or less constant, I'd say, within an hour. When the robot is on the rows navigating, then we usually deploy a machine learning model for the crop weed discrimination task. And that one is a little bit more of a black box. I think that deep learning developers would all agree that, the way that these things work and make their predictions is a little clandestine. I mean, you can kind of, because you're not hard coding the rules that it uses to discriminate between crops and weeds, it learns those rules based on training data, and those rules are not necessarily explicitly interpretable. They're just somehow encoded in the weights of a neural network. So it's really a black box, and you don't really know how well it's going to work until you try it. And so what we do is we deploy the robot, and we very carefully monitor the quality of the crop weed discrimination that the robot's doing. And if that goes well, then we start weeding, and therefore the deployment time is low. But if it's not as good as we'd like it to be, then we would have to retrain the model with data collected from that farm. And then the deployment time becomes a day, right? Because you need to annotate the data, retrain the model, redeploy it, and do a QA and verify it again. So the deployment time is variable, and the variance is mainly caused by machine learning and deep learning and just the innate nature of that.
Interesting. Yeah, that was going to be one of my questions is, are you able to build on a model using all the different field data, or are you training for each field uniquely? And I think your answer was it depends. It depends on the situation.
It does, yeah. Yeah, some fields look like other fields, and so it's fine. Sometimes like the soil type is a little novel, and so you need to kind of refine the neural network's weights with additional training data. But that refinement is not doesn't require as much data as the sort of what it took to train the original model, if that makes sense.
Okay. You kind of have a footing that you can go back to and tune up from a certain baseline. Yeah.
Well, like deep learning is kind of a fine art, really. There is no prescribed formula for like doing this stuff. It's very much, it's very empirical, I guess is what I'm trying to say.
Okay.
It's not as mathematically rigorous and predictable as electrical engineering or mechanical engineering or something like that, where you can really model all the variables in your environment and account for everything, all the forces, for example, and then kind of predict how a certain dynamic structure of some sort is going to behave. With deep learning, it's not so much like that. It's very empirical. You feed it some data, you see what it predicts, and you try to intuit why it predicted what it predicted based on the data that you fed it and the architecture of the model. But most of the gaps in our understanding is filled by empirical experience and intuition. It's very hand-wavy, to be honest with you. And actually, that's one of the criticism of deep learning in general, is that people are surprised by what models do after they've trained them. And you don't get that with like civil engineering. Like people aren't surprised by how a bridge is acting after it's built. They predict it down to every detail. It's all formulaic. Whereas with deep learning, there are mathematical principles at play that we are aware of, like certain theorems, but most of it is completely just kind of completely intuitive and completely empirical. Like, this is what works because, well, we don't know for sure yet. We don't have a theory for it yet, but it works. You get a lot of that in deep learning.
Right. And that's that exact thing is what's held us back from using it in more of our applications. Because when you're in the aerospace industry, when you make a decision about something, it has to be explainable, because when you go through all of the approval process to put a technology into production, you have to be able to say, okay, well, this machine is making this decision because we did this, and I can validate this at each step of the way. So
exactly,
deep learning right now, like you said, it's intuitive. It's not explainable yet. There is people working on that, trying to come up with strategies and algorithms to explain it. So what we've limited ourselves to in the meantime is using, I wouldn't call it deep learning, I put it as machine learning to optimize. So let's say you have a robot path that is going to 150 different points. Well, what's the optimal path that creates the shortest cycle time? And use machine learning to iterate through all the different combinations and converge on an answer of what's the optimal path.
Yeah. No, I definitely think that, yeah, and not to get too philosophical on the subject, but I think that in some ways, when you try to leverage large amounts of data and then ask a machine to use some kind of general purpose algorithm to find patterns in that data and thereby make predictions based on that data, which is basically what machine learning is. In some ways, asking it to be interpretable and explainable, like if it was interpretable and explainable, in some ways you wouldn't use machine learning to begin with. Like the whole idea is that we're trying to model a phenomena that's too complex for us to break down in a reductionist fashion into kind of nuts and bolts and logical rules and proposition statements. And so you use a machine that's more of a black box that is able to just kind of ingest a bunch of data and find patterns in it that you as a human cannot. So it's some ways it's like making a pact with the devil, you know? It really, like you're just kind of saying, well, you know what, if I'm not going to understand it, that's fine, but I just want the results. And
the truth is, it's probably explainable to another machine, but to a person in our bandwidth, we can't explain it because it goes too many layers too deep for us to logically put a storyline together.
Yeah, exactly. And you know, that's honestly the biggest bottleneck we have in our operations is machine learning, because with you know, we've kind of divided our software system into a machine learning front end that essentially takes these camera images and can infer crops and weeds and where everything is in the image plane. You know what I mean? And then we translate that into, you know, the metric space, the 3D world, and then we map things using classical robotics techniques. And then we go down with an arm and we grab the weed using a predictable sort of trajectory that the arm can take. So for us, the variance in our performance is mainly due to machine learning, not the robotics, because the robotics is super kind of traditional and predictable. Now, there are like machine vision systems that are predictable, right? The ones with like hard-coded rules and, you know,
finding edges based upon contrast differences and the mathematics behind it.
Yeah, you can have a modern computer, like a kind of an old school traditional computer vision pipeline that, you know, you need to make sure that every stage in the pipeline works well to get the result that you want, but at least you'll know where it breaks when it does. And that's cool too, but at the end of the day, it's cumbersome to maintain, but also it's just not, it doesn't perform on the level of deep learning. It just doesn't. And that's why we do deep learning and people do deep learning, because you are sacrificing the explainability and in some ways the controllability. But what you're getting, hopefully, if you do it correctly, is the performance. And that's where we're at. And you know, that's partly why people fear artificial intelligence, generally speaking, is not just because of its bewildering ability to like do things that human beings cannot and be much smarter than human beings on whatever task it's been designed to do, but rather just the explainability of it. Like you won't be able to modify it. Like how can you guide something to fit your ethics if you don't know how it's doing what it's doing on some deep level? You know, and that's really it.
Interesting. And you're right. We could get philosophical about the ethics of some of this AI and where we believe it will
Yeah, it
let
doesn't
eventually
go to us,
decide
you
that.
know, the ethics part. Like for
Yeah,
us, we're not worried about that because our machine learning is really just taking an image and telling you here's a weed, here's a crop.
yeah,
It's not making like some kind of like there's no moral component, I guess,
right,
to it, unless you want to get very sensitive about potentially damaging a crop, which is fine.
right,
But
right. If that weed has a soul, or if damaging that weed is infringing on someone's ethics, right?
yeah, exactly. But if you're doing an AI, for example, for, you know, I don't know, like monitoring people's behavior and predicting it, it's like,
Right.
and then you're making policy decisions based on that, then you're in the ethical domain, right?
Yeah. Yeah. Well, so speaking of lines, but relating it to agriculture, of course. Um, I watched some of your videos, and you guys talked a lot about the data and some of the information and predictions that the data can your that's on your roadmap that the data can provide you. For example, what is the current state of the crop? Is there any diseases that the farmer needs to be aware of? Tell me a little bit about, well, first of all, are you collecting are you hanging onto all these data sets for all the fields in order to use it in your future algorithms? And where do you see this taking you?
We certainly hang on to all the data we've ever collected. Um, I'm not sure what you mean by where is it taking us.
Yeah,
Um,
okay. So maybe I can explain it a little bit more. So as I was saying, being able to look at the crop as you're weeding the crop and you're collecting the data about, all the images of the crop and the soil and the where the weeds were at that point. Looking at, let's say, the growth pattern of the crop or the stage that it's at, and using that image or that data to give some information to the farmer that, yes, you're on track, or you're underneath what you should be expecting for growth right now. Maybe there's a problem with your soil condition. Those type of insights is what I was thinking about. It could be very valuable to a farmer with, these large scale operations.
yeah, no, and that's definitely on the horizon for us. Absolutely. Um, yeah, when you have a ground vehicle that with sensors that are very close to the soil, it's essentially limitless what you can do, really. You can collect so much raw data that from you can do like soil sampling, for example. You can do different kinds of imagings like hyperspectral or infrared or things like that that are kind of more conducive for disease detection. And you can definitely do yield prediction or at least analysis of the volume of a plant, for example. Like if you have you can do that with very like typical sensors, RGBD sensors and things like that that have like a 3D, like just 3D sensors essentially. And so you can inform the farmer of like you can collect so much data and have like really informative statistics on all these sort of different subjects. And that's definitely something like we're excited about in the future. We haven't actually done that yet. Right now, we're only focused on weed removal. But that's definitely something that we can work on in an offline manner with the data that we've collected already.
Yeah.
And that's definitely something that we plan on doing in the next year, probably.
Okay. Okay. So let's go back. So we've unloaded the robot. We've mapped the field. You've validated the baseline of your deep learning algorithm, that it's finding the proper weeds, the proper crop, and then you hit go. So how long do these robots typically run, and are you there at the field for the growing season, or you're there for a couple days and you move on to the next farmer? What happens next?
Yeah, well, usually farmers plant in succession. So there's all like we essentially target crops that are very young. And the reason we do that is because we want to, our main focus is pulling the weeds that are very, very close to the crop. because those are the weeds that need a human hand, and those are the weeds that cannot be removed with a cultivator.
Okay.
And so in order to do that best, we want to target it before the crops are way too old, because when they're young, that's when the crops have to compete for nutrients with weeds. And that's when weeding matters most. So we make sure that we're on a field where the crops are young, and when they're no longer at the stage where we care for them, we go to another field, whether it's on the same farm or otherwise. It depends on how things are planned on the farmer and how they plant things. But usually farmers that plant in succession, which means that you've got a field, say like imagine like a few acres, and then the first 10 rows you plant, and then the next 10 rows you plant like a few weeks later, et cetera, et cetera. And so our robot just kind of always moves such that it's at the growth stage that is applicable. Yeah, and it works for hopefully, like on our best day, it works for 20 hours a day. Okay. And the reason is because we still want to monitor the robot while it's operating, and therefore leaving it, like we do leave it alone doing its thing for several hours a day, but we try our best to like keep an eye on it, at least for the time being.
So you're sleeping 4 hours a day, basically.
No. Well, we have different kind of shifts, and we've organized it in a way where no one is, stressed, because it's not fun. It's not fun work, and we do our best to kind of monitor the health of the robot so that we kind of automate the monitoring itself. Okay. There are some things, however, that we have yet to figure out how to automate, and therefore you just need a human eye watching. And that's actually one of our pain points, and that's what we're working on right now.
Okay. Is that something you mind sharing, or is that something that is more of a trade secret for you guys?
Yeah, it's a little too involved. Okay. It's very particular to our system, and so I'd rather not.
Okay, no problem at all. We have those topics too. That's not an issue at all. So which regions are embracing robotics the most for you? Where do you get the most like excitement and I guess pull from customers where they just are looking for help and they're innovative? Is there any particular areas, regions of the world that you find are the most innovative?
I'd say like California is very innovative. I think that it being in proximity to like Silicon Valley and such, like most farmers there are much more kind of agreeable to the notion of robotics than they are in other places. That's something we've noticed. But farmers are pragmatists. They really, really don't ultimately care about how it's done as long as it's done. And so we haven't gotten a lot of resistance to the kind of novelty of it. Some farmers are more skeptical than others, and the ones that are less skeptical are the ones that are more used to having cutting edge sort of technologies tried on their farms and stuff like that. And that's been in California as far as we've observed. But like Quebec farmers, Ontario farmers that we also work with, they're skeptical, of course, and rightfully so. But they ultimately don't really mind what it is that you're trying, as long as it produces the value that you're proposing.
Okay. Now, is there any regulations? I see this in other areas of robotics. I had a gentleman on my podcast that right after the city of Toronto banned sidewalk robots, which really put a damper in a lot of startups' hopes for growing their business in Ontario. Is there any regulations that are coming online that are either helping or hurting your business and introducing robotics into agriculture?
Nothing has hampered us so far, thankfully. One of the conditions is that we have the robot needs to be, one of the conditions actually for the design of the robot was for us to have like range detectors, like LiDARs essentially at the front and back of the robot that can detect if there's some kind of vertical structure in front of the robot, usually a human, for example. and that the robot automatically pauses in that situation.
Okay.
So there are like some legal requirements for safety measures like that. But otherwise, it's been fine for us. Like we haven't been hampered by any legalities, let's say.
Yeah. One of the current events, I think it was this summer, there was the protests in the Netherlands for the Dutch farmers about the Dutch government putting a lot of regulations trying to reduce the amount of nitrogen being released, which is, nitrogen is used in fertilizer quite heavily. And that spread into Canada. There was a lot of support for the Dutch farmers in Canada. There was protests here, and the Canadian government, I don't know if they've regulated or they're signaling that they want to reduce the emissions as well too. But when I'm sitting in a quiet room and thinking about what you guys are doing in the data, maybe there's a day where we could be adaptively fertilizing the fields based upon crop growth and the progress at different stages.
Yeah, totally. I mean, there are a lot of technologies aside from ours that do like spot spraying fertilizer.
Okay.
So they like, instead of just kind of willy-nilly spraying with like, you know what I mean? Like just with
Just
an
mass
airplane.
spraying everywhere.
Yeah. Instead of mass spraying, you can just kind of like just spray the crop directly. And that definitely is I like that a lot because it just saves fertilizer and is a little more effective. So yeah, definitely, I definitely think that technologies ultimately, like when you want to combat things like like whatever environmental concern you have, the solution is technological ultimately. And so yeah, I definitely think that technologies like ours that are like precision ag tech is the way to go, and investing in those things is the best. I definitely think that that's the way to go. I don't think that taxing farmers who are already very low margin businesses that a lot of revenue, a lot of spending. That's what a farmer is. So that they're not walking away with much, and you want to tax them further. It's like, I don't think driving food prices up for kind of the average human being is a solution to whatever problem they think there is, which I barely agree that there is one, but that's a different topic.
Yeah, no, you're right about that. And I think I mentioned I grew up on a farm, and any of my friends that are still in the business, it's because as their family grew, they bought farms and they were able to consolidate and get a certain massive acreage that they could sustain a living. I think there was a stat preparing for this conversation. There was a stat that since the 70s, the number of farms in Canada has halved, and it's not because the farmland went away. It's because they've consolidated. So it's a really big business run industry right now. And by adding more taxes to the farmers, you're just going to weed out the smaller operations. So it'll be harder to for independent farmers to survive. That's who I believe will suffer in all this.
Yeah, and it's crazy because the Dutch farmers specifically are the most efficient farmers in the world.
Yeah, I've heard that too. Yeah.
Yeah, because they produce so much agricultural product, and they do it on a very small amount of land. And for us to go after them, for their government to like kind of go after them in the name of a ambiguous virtue that I don't even think is, it's extremely frustrating. And the same thing is going to happen here. And the prices we pay for groceries. Well, what's funny is that when you go to the store, you're just going to be buying fruits and veggies that are imported from countries where they're not regulated, right? And therefore the prices are lower. But us growing our own food is going to become more difficult because doing that's going to cost so much that when you go to the grocery store, you're going to buy an apple from Mexico instead of an apple from Canada. And that's the consequence here.
Yeah.
And I just don't like it. I think it's a bit terrible.
Yeah, I agree. So now that you're in robotics, you didn't start out as a robotic engineer, but now that you are, are there problems or solutions that you think would be very cool or important that you wish you just had more time to solve?
in the context of our particular product?
It could be, or it could be, something, a pastime, or a hobby.
Huh. Interesting. I don't know if I can say off the top. Let me think.
Putting you on the spot.
Yeah, yeah. Yeah, I mean, if I had the ability to redesign our robots, for example, from scratch again, I would make some different decisions. I would use different cameras. I would use a different sort of inertial navigation system. We're actually working on these changes for the next versions that we build, but the ones that we've built already that are kind of set in stone and are being kind of commercially deployed, I think they're fundamental decisions made a little differently. You don't know what you don't know at the time. I mean, they're definitely more than good enough. That's for sure. But looking to improve the product, I would definitely I would use different cameras for just very technical reasons that I don't want to get into. I would definitely do that. I would use inertial navigation systems that are a little more accurate vertically than ours, giving us much better control in terms of how deep to go in the soil when we pull.
Okay.
That's definitely a change that I would make. One of the debates we have is, should we build robots or should we build implements that are pulled by tractors, right? That can house your sensors and your actuators and do the job. Pros and cons to each. And I'm still kind of 50-50 on that. My opinion on it is evolving, but perhaps had we just built implements to begin with, maybe that would have been a better sort of I guess we would not have had to worry about navigation, because we would put that on the farmer and we would only worry on the exact value that we're proposing. But obviously having your own robot means that you're more in control, and that's the benefit of what we did. And so there's pros and cons on those two, and I wonder about that a lot. But having an implement version of our product is definitely also a part of our future. So there's those two things. I would definitely include drones in our setup, not for the weeding itself, but for the field surveying and you show up, you use a drone, you go over the field, and you can do a lot of preliminary stuff very quickly. Like you can figure out where there's most weeds on the field with a drone. You can also map the GPS points and kind of map the field and see how the rows are curving and all of that from like a top-down point of view. And then it can relay that information to a ground vehicle that will be a bit more specific in what it has to do. That's definitely something that I wish we did. But again, like all of these wishes, we still can do them in the future.
Absolutely. That sounds like a great upgrade.
Yeah, that's definitely, and like the drone can literally like park on the top of the robot, and it can just do that, and then it can be like your ability to kind of look ahead and then see where it has to go. Lots of exciting fancy stuff that we can do for sure.
So you guys have quite a technology stack in your solution, from just the robotic and the robotic standpoint and the autonomy standpoint through to the deep learning and all the data that you guys leverage. Over the next 4 or 5 years, what developments or what things could be important to your industry, that if somebody was out there working on something that would be beneficial?
Like in the next 4 or 5 years, what do we think we will focus on?
No, or if you had a wish list of things maybe you're not working on necessarily, but you'd say, what, from what I've seen in agriculture, in our industry, or in robotics, that could be really killer.
Harvesting, 100%.
Okay.
Harvesting. That is a very unautomated area. I mean, okay, I don't want to speak too soon. There are automated harvesting solutions for certain crops, but most of them suck, to be honest, and are not very much used. And the ones that are used are, only specific to a certain crop here or there and need to only work in certain situations. So there's just so much development to be done in harvesting. And that's honestly, for me, that's what I want to do next.
Okay.
After the weeding. Yeah.
Okay, interesting. Last question. So what do you do in your spare time, Jad?
I play soccer and go to the gym a lot. I like the athletic side of life,
Yes.
especially while I'm like still relatively young. You know, you want to kind of squeeze the juice while it's there. You know, I don't want to like, you know, look back and be like, oh, I wish I like did more physical stuff when I was like in my athletic prime. You know.
Yeah.
So I try to do that as much as possible. I like music. I like playing the piano, and I like reading. And that's basically it.
Oh, very cool. Like, I'm still a soccer player myself, so
Oh,
even
nice.
when you get old, it's something you can still do. I don't have maybe the same fire that you have by the sounds of things, but
Yeah,
still to
I've
get
been on
out.
playing for a long time, for sure.
Yeah,
But I just want to like see how essentially how good I can get while, you know, I'm still young and I can kind of like run as fast as possible and all that
yeah,
stuff.
okay, right on. Any good books on your bookshelf?
I'm just finishing a book right now that was published in the 2000s by Melanie Mitchell, who's a computer scientist, and it's called a guided intro to complexity. It's about complexity theory in general,
Okay,
and just like a general theory for complex systems, which is actually the most general theory you can ever come up with because everything is a complex system.
yeah,
And it just talks about how the need for such a theory has arisen as a result of the development in many different fields, evolutionary biology, like the biology of genetics, for example, as well as just systems theory, like how networks behave, and as well as computer science in itself, like evolutionary algorithms and such stuff like that, and how they all are underpinned by similar kind of principles, and just trying to kind of abstract all those different fields into like a unifying theory of complexity, which still has not been done. And yeah, it's just an awesome book. That's what I'm into right now.
yeah. Okay. It sounds really applicable to your role and your job at work, actually.
Yeah, I try to keep it like that. I mean, I don't read novels. I read
Yeah,
kind of more technical books because they're more interesting to me. I mean, you know, everything's a narrative, even the technical stuff. It's a story, right?
yeah,
So yeah, but I don't read like fiction narratives with like characters and, you know, stuff like that. I'm not into
yeah,
that.
yeah. Hey, Jad, I really appreciate you taking some time with us, and it's been a fascinating conversation. And thank you for your time, and I wish you a great rest of your day.
Thank you. Thank you for your time, and this was a good chat.
So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.